Welcome to Worldwise Studio, where the world's biggest ideas become surprisingly simple.
For over 100 years, the global economy ran on a liquid foundation. We pumped fossil fuels out of the earth and burned them. But today, the mechanical systems powering our world are changing, and they require a completely different kind of extraction. Instead of crude oil, tomorrow's hardware relies on hard rocks. We are talking about lithium, copper, cobalt, nickel, and rare earths. These raw materials are the literal building blocks of electric vehicles, renewable energy grids, and the processors inside our smartphones. Look at this massive industrial complex. In the 20th century, if a nation had sprawling oil storage tanks and refining capacity to process crude, it held immense geopolitical leverage. The wealth and military reach of entire empires were measured in barrels. Now, look at the scale of this extraction site. The new metric of power is measured in millions of tons of earth. Securing the materials for a modern digital economy requires carving vast, terraced open-pit mines to find highly specific, tech-critical ores. Nations that control the supply of these specific rocks will dictate the pace of technological innovation. They will control the fastest computers, the most efficient batteries, and advanced military hardware. Artificial intelligence and cloud computing are frequently marketed as weightless software existing only in the digital ether. But the physical reality looks like this. The cloud is actually a network of dense, heavy server racks housed in massive data centers. Running complex AI models requires thousands of specialized microchips, industrial-grade water cooling systems, and thousands of miles of copper wiring to handle the massive electricity load. We see a similar physical reality in the automotive industry. Combustion engines are being replaced by heavy battery packs comprised of thousands of lithium-ion cells. These vehicles require far more raw physical matter to manufacture than their gasoline-powered predecessors. Building millions of these batteries and data centers requires billions of pounds of raw material. Nature did not distribute these minerals evenly, and obtaining them requires sifting through billions of pounds of earth, often in a handful of isolated geographic regions. Because of the sheer tonnage of copper, lithium, and rare earths required to build the energy grid and the AI models of the future, we are currently witnessing the largest surge in physical resource extraction in human history. This mass-scale industrialization creates complex new geopolitical vulnerabilities. It is easy to assume that if a country has huge deposits of lithium or cobalt within its borders, it automatically wields vast economic power. To understand why that isn't true, we need to trace the modern supply chain. It starts here, at raw extraction sites in places like South America, Central Africa, and Australia, where the physical dirt is pulled from the ground. That raw dirt does not stay local. It is loaded onto cargo ships and transported thousands of miles across the ocean, converging almost entirely onto just one or two specific regional processing hubs in Asia. Once those facilities process the raw ore, they package the refined materials and ship them back out. They bounce across oceans again, moving to factories in Europe, North America, and other parts of Asia to be assembled into microchips, battery cells, and eventually final consumer products. This highly fragmented journey means a single piece of technology relies on a massive cross-border network. A disruption at any one node, a closed port, an export ban, or a natural disaster can instantly paralyze production for companies thousands of miles away.
The tightest bottleneck in this entire network sits directly in the middle. Look at this heavy industrial processing and refining machinery. Raw rock straight out of a mine is essentially useless to a technology company. To make it work in an electric vehicle or a smartphone, that ore has to be baked at extreme temperatures, soaked in harsh chemicals, and purified down to an exact battery-grade specification. Building these refining facilities takes years, costs billions of dollars, and carries heavy environmental risks. Because of that, a few nations spent the last few decades deliberately subsidizing and monopolizing this specific step in the supply chain, while the rest of the world looked away. Owning a mineral deposit gives a country something to sell, but owning the only facility capable of purifying that mineral gives a country total leverage over the buyer. If you control the refinery, you control whether that metal ever makes it to market. Governments are no longer fighting over who owns the dirt. They are fighting to dominate the industrial choke points that actually turn that dirt into technology. Recognizing this vulnerability, Western governments are now directing billions of dollars toward aggressive countermeasures. They are funding new refining facilities and rewriting trade policies to bypass established choke points. But completely domesticating the entire process is physically and economically impossible. No single nation possesses all the raw minerals, the cheap energy, and the environmental capacity to handle every step of production entirely within its own borders. That hard reality has led to a new geopolitical doctrine: supply chain resilience. The goal is no longer total independence. Instead, governments and corporations are building redundant pathways. If a primary trade route snaps, they want multiple, smaller backup lines already in place to absorb the shock. The constant threat of disruption is also forcing companies to adapt their engineering. Automakers are heavily investing in alternative battery chemistries, but use cheaper, more abundant materials, while expanding domestic recycling programs to harvest usable metals straight from old devices. National security in the 21st century requires a broader perspective. Defending a country relies heavily on funding defensive industrial infrastructure and securing commercial supply chains, long before any traditional military action is needed. We are watching a dangerous friction point develop between two vastly different timelines. Software companies can release new artificial intelligence capabilities in a matter of months, but permitting, funding, and building a new copper mine or lithium refinery takes an average of 10 to 15 years. Look at this sprawling network of high-voltage transmission lines. The true limits on the AI revolution and the transition to electric vehicles are strictly physical. Expanding these industries requires massive upgrades to raw material supply chains and the physical electrical grid. Every seamless digital interaction, every electric mile driven, and every algorithmic query is physically tethered to an incredibly complex, fragile global network of rock, heavy machinery, and cargo ships. As the global economy fully electrifies and digitizes, the balance of power is shifting. Geopolitical dominance now belongs to the nations that successfully control the sprawling, invisible web connecting the mine to the machine.